Okay, this is the first revision session for C1 air quality. This is the first part. Okay, what are we going to do first? Okay, well what we're going to do, we're going to have a look at the OCR specification. This is very handy because it will tell us exactly what you need to know. Okay, the first thing I'm going to draw your attention to is it says recall, recall, recall. That basically means you just need to know it, and you need to be able to just provide that information in the exam. So you need to know the gases that are in the Earth's atmosphere, not any other planet, just the Earth's atmosphere. Okay, you need to recall a little bit about the particle theory, about gases consisting of small molecules with very large spaces between them. We'll cover that. You need to know the percentages of these gases, so nitrogen, oxygen and argon. That's actually approximate 1%. Okay, and this is an important one here. You need to understand that other gases or particulates may be released into the atmosphere by human activity or natural processes, e.g. volcanoes, and that these can affect air quality. So you need to understand that, and you need to be able to write clearly about those gases and how they can be caused by natural, e.g. volcanoes, or human activity. Okay, so we're going to take a look at gases in the atmosphere, or more specifically, gases in the Earth's atmosphere. Okay, obviously the first one is nitrogen. Okay, and what they actually mean is nitrogen gas. So nitrogen gas is actually diatomic, so there are two nitrogen molecules sitting close together. That can also be written as a symbol like this, N2. Notice the 2 is a subscript down there. It is not N2, that is completely wrong. Okay, you won't get any marks if you're sloppy like that. It does matter, okay? So that's N2. The other one we got here is oxygen, and that's two oxygen molecules sitting together. So as I was saying, that's diatomic. Okay, the third is 1% of the atmosphere. That is made up of argon, and we have smaller quantities of other gases like CO2, carbon dioxide, water, H2O, and a few other gases we'll cover in a few seconds' time. Okay, if you recall, the third item that you need to know about was basically key stage 3 information. It was talking about small particles, large gaps, which is a rather sloppy way of describing gases. You remember at key stage 3 you had solids where you drew all the particles close together. Okay, there was a small amount of movement, so you sometimes drew little arrows like this. Then you had liquids where they were randomly arranged, and these items, these molecules were moving around. And then you had gases, just a small number filling the space. Okay, well let's just take this out of the way and just confirm what we're actually talking about. So mostly when we've got gases, we're talking about mostly empty space. So I'm drawing little dots there. Arguably I should draw the little dots next to each other to show that we've got oxygen or nitrogen. Okay, as we say, with gases it's mostly made up of nothing and small molecules moving around randomly. That's what you need to know for this section. Okay, so let's look at these other gases in the atmosphere. Let's recap what we've got. We've got sulfur dioxide, that's one sulfur, two oxygens, so that's why it's SO2. Carbon monoxide, mono meaning one, so that's carbon monoxide. Carbon dioxide, so di meaning two. Nitrogen monoxide, there's the one. Nitrogen dioxide. We've got particulates and we've got water. Okay, so sorry, SO2. Okay, now this will react with water. Okay, and oxygen, and this will produce acid rain. Okay, this will harm trees and plants and also damage buildings. Okay, take that out, leave a bit more space for the next one. Carbon monoxide. Some of you will recall that this is due to incomplete combustion, and it's also poisonous. So carbon monoxide, let's just do that one, CO. Okay, that's poisonous. The reason it's poisonous to us is that the hemoglobin in your blood would rather carry carbon monoxygen than oxygen. So that causes you to slowly suffocate internally, and all your cells in your body slowly die. Okay, so that's carbon monoxide. Carbon dioxide, that's the greenhouse gas. Okay, again, no, little 2 down there, very important. Okay, extra little bit of information for you. Okay, that will dissolve. That will dissolve in rainwater and also seawater. So some of it will come out of the atmosphere. Obviously plants use it for photosynthesis. Okay, but as we've just mentioned, it's a greenhouse gas. Increasing levels of CO2 will trap more energy in the earth and cause the temperature of the planet to increase. So that's carbon dioxide. Okay, let's clear a bit more space here. Sure, there's a quicker way of doing this, but anyway, here we go. So next thing we're going to look at is nitrogen monoxide. As you know, mono is 1. Okay, that will react in the atmosphere to produce nitrogen dioxide, and that will react with water and oxygen. And that will also produce acid rain. Okay, there's some evidence that it can also make asthma worse. Okay, so not particularly nice. Okay, so particulates, this is something that we've all seen if we're in London or you live near a road. All the black sooty particles that you see on your window shelves and on your front door, that's due to solid little parts of mostly carbon in the fuel. Okay, and water in the atmosphere, not a problem, pretty harmless, unless there's a lot of it, in which case if you can't swim then that's a bit of a problem, but that's okay. That's water vapour in the atmosphere. As we all know, that can be formed into clouds. Okay, you need to know about parts per billion. Okay, let's be clear. What is a billion? Okay, that's 1,000. Okay, that's 1,000,000. And 1,000 million is a billion. Okay, and parts per billion basically means if, for example, we had 1,000,000,000 air molecules, and I'm not going to sit here and do 1,000,000,000 air molecules, but just imagine we had 1,000,000,000 air molecules. If one of them was the particle that we're interested in, that one, there, that's our 1 part per billion. Okay, What do volcanoes do? Okay, they can produce sulfur dioxide, which can produce acid rain. They can produce CO2, global warming gas. Carbon monoxide, poisonous to us. Nitrogen monoxide and nitrogen dioxide, although by the time it comes out it's probably turned into nitrogen dioxide. And water vapour, and lots of particulates. Also, all of that can be produced from burning fossil fuels. It's basically the same list.